press, I press rewind to see that face one more time. And I got this sold up. Remy boys, they know us. All fast money, no slow bucks. No hurricane control us. Yeah, baby. Baby girl, you're so damn fine though. I'm trying to know if I can hit from behind though. I'm sipping on you like some fine wine though. When it's over, I press rewind though.
So hello everyone, I'm Jude Pascual from Rizal National Science High School. So today I'm studying about mathematical induction. So since I'm done studying it, let me share my knowledge to you. What is mathematical induction? Mathematical induction is a method of proving theorems and mathematical conjectures, and is used to present formal and valid proofs.
Rewind to see that face one more time, and I got this soul.
So let's start our tutorial.
All fast money, no slow bucks, no hurricane controllers.
So this is the first example. The conjective of the sum of the first positive odd integer where n is equal to n squared. So I'm gonna show you first the table. This is the values of n, sum of integers, and the values of n squared. If n is equal to 1, sum of integers is 1, which is odd number. N squared is 1 squared. So 1 squared is 1, and sum of integers is 1. If the value of n is 2, 1 plus 3 is the sum of integers, and n squared is 2 squared. 2 squared is equal to 4, and 1 plus 3 is equal to 4. And so on and so forth with the other values of n. So this is the equation of the given conjective. 1 plus 3 plus 5 plus 7 plus 9 plus up to 2n minus 1 is equal to n squared. So I know some of you are asking, where did I get 2n minus 1? I just got it from the arithmetic sequence formula. So the arithmetic sequence formula is a sub n is equal to a sub 1 plus n minus 1 times d. So a sub n is equal to a sub 1 is 1. 1 plus n minus 1 times the common difference, or 3 minus 1 is 2. It's equal to 1, 2 times n, 2n, plus 2 times negative 1 is negative 2. So distribute 2n minus 1. So there we go. So there, we got the answer 2n minus 1. So these are the steps in mathematical induction. Step 1, the basis step. Show that P1 holds true, so let n be equal to 1. Next is inductive step. Induction hypothesis. Show that Pk is true. Next is show further that Pk plus 1 is true whenever Pk is true. And lastly, conclusion. You should put therefore P sub n, whatever the n values is, holds true for all or some positive integers. So let's start with the step 1, the basis step. Don't forget that we should let n be equal to 1. So let's put the formula or rule. 2n minus 1 is equal to n squared. Replace n by 1. 2 times 1 minus 1 is equal to 1 squared. 2 times 1 is 2 minus 1 is 1. 1 squared is 1. And there we have proven that the rule or formula is true if the value of n is 1. So let's now go to the first part of the inductive step, where we're going to show that Pk is true to the given equation. So all we need to do is just copy the equation. 1 plus 3 plus 5 plus 7 plus 9 up to plus 2n minus 1 is equal to n squared. All we need to do is replace n by k. So 1 plus 3 plus 5 plus 7 plus 9 up to 2n 2k, minus 1 is equal to k squared. So let's go now to the second part of the inductive step. So we need to write the first equation, which is 1 plus 3 plus 5 plus 7 plus 9 plus up to 2n minus 1 is equal to n squared. And the derived equation from the first part of the inductive step where we replace n by k. So 1 plus 3 plus 5 plus 7 plus 9 plus up to 2k minus 1 is equal to k squared. So here, in this third step, we're going to let n be equal to k plus 1. First is we need to copy the left side of the equation of the n is equal to k. So let's copy this. 1 plus 3 plus 5 plus 7 plus 9 is up to plus 2k minus 1. So after that, we're going to replace this formula 2n minus 1 and n is equal to n squared. We're going to replace the values of n by k plus 1. So we're going to replace it plus 2 times k plus 1 minus 1 is equal to replace n by k plus 1, k plus 1 square. So, since 1 plus 3 plus 5 plus 7 plus 9 up to 2k minus 1 is equal to k squared, we're going to replace it by k squared. Then copy the remaining variables. So, plus 2 times k plus 1 minus 1 is equal to k plus 1 squared. And after this, we're going to solve the equation and prove that it is equal. So now let's solve. So copy k squared. Distribute 2 by k plus 1. 2 times k is 2k. 2 times 1 is 2. Plus 2 minus 1 is equal to k plus 1 squared. So k squared, 1 times k times 2 is plus 2k plus 1. After that, we're going to solve this, the left side of the equation. So copy k squared plus 2k. 2 minus 1 is 1 plus 1 is equal to k squared plus 2k plus 1. And there we go. We have proven that the two sides of the equation are equal. So don't forget the third and last step, the conclusion. This is the most hardest part. No, just kidding. So we're just going to write that. Therefore, Pn holds true. Since we have proven that the two sides of the equation are equal to all positive odd integer. So this is the second example. Let's do the basic step or the first step, where we're going to let n be equal to 1. So let's just copy the rule or formula. 2 times n is equal to n times n plus 1. Replace n by 1. 2 times 1 is equal to 1 times 1 plus 1. 2 times 1 is 2 is equal to 1 plus 1 is 2 times 1 is 2. And there we go, we have proven that it is equal. So let's go now to the second part, mathematical induction, the inductive step, where we let n be equal to k, the first one. So first, copy the first equation or the conjective. So 2 plus 4 plus 6 plus 8 plus up to 2n plus 2n is equal to n times n plus 1. don't forget that I just derived 2n from the arithmetic sequence formula. So, next, we're going to replace the values of n by k. So, 2 plus 4 plus 6 plus 8 plus up to 2 times k is equal to k times k plus 1. That's it. Let's go to the next step. So now, we're at the second part of the inductive step, where we're going to let n be equal to k plus 1. Don't forget that we're going to base from the first and original equation or conjective, which is 2 plus 4 plus 6 plus 8 up to 2n is equal to n times n plus 1. To the derived equation from the n is equal to k. 2 plus 4 plus 6 plus up to 2k is equal to k times k plus 1. So the first part is, we're going to copy the left side of the equation where n is equal to k. Here, 2 plus 4 plus 6 plus 8 up to 2k. So 2 plus 4 plus 6 plus 8 plus up to 2k. And then, we're going to use the rule or formula in the first conjective and replace n by k plus 1. So, plus 2 times k plus 1 is equal to k plus 1 times k plus 1 plus 1. Now we're going to show that the left side of the equation is equal with the right side of the equation. So, don't forget that 2 plus 4 plus 6 plus up to 2k is also equal with k times k plus 1. So, we're going to replace it by k times k plus 1. Then, copy the remaining variables. Plus 2 times k plus 1 is equal to k plus 1 times k. 1 plus 1 is 2 plus 2. So k times k is k squared. K times 1 is k. Plus 2 times k is 2k. 2 times 2 is 2. Is equal to k squared plus 3k plus 2. So, k squared, k plus 2k is 3k plus 2 is equal to k squared plus 3k plus 2. There we go. We have proven that the conjective holds true for all even numbers. And the last step, conclusion. Let's put therefore Therefore, Bn holds true for all positive even numbers. And that's all. So guys, I hope you learned a lot from me. So if you have some questions, feel free to comment it. I hope you will not forget these steps. Step 1, the basis step. Step 2, the inductive step. And last step, the conclusion. So, see you in my next tutorials. Thank you for watching. Thank you for watching.
Secrets to yourself. It's Kama Sutra show and tell.